In this video, I'll be covering custom error types. Custom errors allow you to be specific about problems that may occur within your program. Here's some of the ideas about why you would want to use custom errors in your program. Functions may fail in more than one way, and it is beneficial to know exactly how the function failed, so corrective action may be taken. It's also useful to just communicate what happened when a function fails, even if you don't plan to do anything. When you're creating custom errors, you'll generally want to use an error enumeration because enumerations make it easy to add new errors and they can be easily matched upon later. Having a proper error type has a few requirements. First, you need to implement the debug trait, which can be derived. The debug trait is for displaying what happened in the context of development and debugging. You also need to implement the display trait, which has an example in the standard library documentation, so it can just be copied and used really easily. The display trait is considered a user-facing trait, so the message should reflect this. Lastly, we need to implement the error trait itself so we can get interoperability with other errors. Implementing the error trait can actually be done with an empty implementation block because the trait has default implementations. We are first going to implement all of this manually to understand how it works, and then we will use a popular crate which automates the entire process. In this example, we are working with an automated door locking system. We have three possible errors that may occur when trying to lock a door. We could have a mechanical error, a network error, and they could just not be authorized to open the door. The first implementation that we need is debug, which is easy because we can just use the derive macro. So we're already 1/3 of the way there. The next thing we need to implement is the error trait, which is present as part of the standard library within the error module. You want to import error with a capital E. Writing the implementation details is actually optional because the trait has a default implementation for everything needed. So we can just use empty curly braces here at the end to indicate that we want the defaults that are already part of this trait. The last thing we need to implement is the display trait. Now, implementing display is a little complicated, but the docs has an example which I always just copy and paste whenever I need to implement the trait. The only thing I changed is the body of the FMT function here. Within the body, the implementation simply matches on all possible variants that are present in the lock error enumeration. The details of this function signature are specific to the display trait, and we're not going to go too much into detail on that because it's not really needed for this lesson. The write macro here is just like the print line macro, and actually the write macro is what the print line uses behind the scenes in order to format everything. The only difference with the write macro is you'll need to provide this formatter here first, and then you can pass in a string along with any parameters you want for your tokens. Now that we've seen the long manual way to implement this, let's see how we can do it automatically using a crate. The crate we'll be using is called thisError. To utilize it, the first thing we need to do is add the crate to our cargo.toml since it is an external crate. So if you open up your cargo.toml, under your dependency section, you'll just add thisError equals 1.0. Once that's done, we can jump back to the code. To use the thisError crate, we'll use thisError, and then we'll access the error trait from that crate instead of the standard library. In addition, on our derive, we'll have debug, and we'll derive error. In our enumeration, we have a few annotations here. So these annotations are what automatically implement the display trait. So we'll do error, and then the message we want displayed, and then that message will be displayed whenever the error occurs, and we want to print it out. This 0 here within the curly braces, that's accessing the 0 here in this tuple struct. So this is number 0, and then if we had more information, like if we had another I32, then that would be 1, 2, 3, etc. These variants don't have any associated data, so all we can do is just present a message for the user. Let's take a look at how to use this in a program. Remember that the result type is just an enumeration. This first one here is the type that we get back when the result is okay, and this is the type we get back when the result is an error. To return the error, we can just use the ERR variant of the result type and just put our error in, and that'll get returned as an error. One last thing I want to go over is error conversion. Here in our lock error, we've changed our network variant. Instead of just having no data, it now has a network error type, which is seen right here. We also have an additional annotation. So if we annotate this with from, what will happen is if we get a network error, it'll automatically convert into a lock error if needed. And that's because we have this from annotation here. So we can convert from a network error into a lock error. When we do that, the lock error will be a network variant. The specifics of how this is accomplished will be discussed in a later lesson on type conversions. I just wanted to mention this now since converting errors is a very common thing to do. There are a lot of things that can make errors either fantastic or cumbersome. Here are some pro tips to ensure you get the most streamlined experience with errors. You'll always want to prefer error enumerations over strings when you're working with errors. Enumerations concisely communicate what went wrong with the function, and they are checked by the compiler, so you can't mess up. In addition, the variants can be matched on, so different code paths can be taken based on what type of error occurred. Again, this is checked by the compiler, so adding new errors will never result in dead code paths. Now, I know I just mentioned to always prefer enumerations over strings, but when you are prototyping or you don't exactly know what kind of errors you should generate, then strings are fine to use. However, once this information is better known, or when your code starts forming into a better shape, then switch over to error enumerations. You'll also want to keep your errors specific. And what do I mean by this? Basically, error enumerations should either be module specific or function specific. When working with modules, all the functions within should be related and should theoretically mostly have the same type of errors. Making an error that covers things that go wrong within that one module would make sense, since all the functions should have similar semantics. Some functions may have many error conditions, or an error that is just out of place when compared to the rest of the surrounding code. It's better to make dedicated errors for individual functions instead of trying to make it fit in some module level error. The this error crate makes it easy, so there really is no reason not to make an error just for a single function, if it seems appropriate. The last pro tip is to use match as much as possible. Whenever the error enumeration is updated, you'll get a compiler error for all of the code that utilizes the enum. This ensures that every possible code path gets covered. There is also one really important pro tip. Never put unrelated errors into a single enumeration. If you do this, eventually your enumeration will just have every error in it, and matching will become problematic. Since enum variants get checked across the entire codebase, if you put all the errors into a single enumeration, you'll have to update code that never handles a specific error just because it happens to utilize the enum. This makes updating errors difficult. Lastly, lots of error variants in a single enum make it impossible to know how a function can fail without inspecting the function. This means you'll either spend a lot of time reading functions you don't need to, or matching on errors that will never happen. To recap, custom error enumerations communicate exactly what went wrong in a function. Errors require 3 trait implementations: the debug trait, which can easily be derived, standard error, and you can just do an empty implementation, and the display trait, which you can implement manually or use a crate to do for you. You'll want to use the this error crate to easily implement all the required traits for errors. That way errors are simple to make. And you'll also want to keep error enumerations module or function specific. Don't put too many variants in one error, that way you can avoid problems later.